There we go. So I'm going to share our screen, and then that's why we have slides, honestly. I don't know about you guys. Yeah, that was kind of look like before. He cut his hair. But that was, he used to have short hair, and then during the pandemic, he didn't let it grow. I mean, he didn't cut his hair, so yeah.
I would not recognize. Oh, it looks like an empty slide in
Yeah,
there.
yeah, Ken.
Sorry, yeah. Yeah, so that's actually a picture in Cancun at one of our field sites from a couple of years ago. So.
I was too very do kind of want to have short hair.
I know. Okay, so you just talk here, it's being recorded, and then we'll see on the screen there. Okay, so one of the reasons you guys know, so if your words leave you, that's the great thing about having slides and presentations like this, is then you can read the slide and it will remind you what you were supposed to be saying. So yes, this is what we use it for. Okay, so next will be on microplastics.
Okay. Hello, everyone. Thanks for supporting us in our research. My name is Alexis Moreno, and I'm going to be presenting about microplastics in the cenote of the Yucatan Peninsula. So just like my colleagues have already explained very well, that the Yucatan Peninsula is a flat terrain. It's very porous and it's made of limestone, so that allows for lots of erosion to happen in this area. And that'll become more important later when I introduce plastics. That's an empty slide, oops, okay. So there's two primary types of plastics. The first one's called primary, and that comes from the manufacturing, what we make and the different products that we purchase. And secondary types of plastics are those which break down and fragment from the primary types of plastics. There hasn't been much research done thus far about microplastics, so for the purposes of this research experiment, I'm going to be defining them as anything between, I believe that should be 0.3 micrometers and between 5 millimeters. And the thing about plastics, some of the research papers that I had been reading say that there is global distribution of plastic particles as well as remote distribution. So they've been found in places that maybe people haven't necessarily been, but with currents and wind, just like this image demonstrates in the bottom right, the plastic can transport throughout the world. Okay, and then here is an image of different forms of plastic. You know, as the water break them down, as the wind breaks them down, or they get softened by wind and water, they form these different shapes, and they come from different plastics. Like you see the sheet plastics here, that could be from like plastic wraps and things like that. There's spheres, fibers, and fragments. So when I do my research, I'll be looking for these sorts of shapes, but there will be no way to actually determine if they're actually plastic, and I'll discuss that more a little later. So I'm gonna actually go back to this picture here on the left, where we see that there's different ways that water is entering into the aquifer at the way bottom of the diagram. And that's important because, as we see on top, there's a lot of population. We see the septic tank, and there's one all the way to the left that says sinkhole, uses trash dump. So that could be possible ways that microplastics are entering into the aquifer, if I do in fact find any there. Okay, so my hypothesis is, this real quick, I'm sorry, picture now. Okay, so my hypothesis is that near the sources of groundwater where there's lots of tourism, that there will be more plastic, larger accumulation of plastic there than in the places that are a little more remote. But again, plastic can find its way anywhere through the different, through wind and water. And then my second hypothesis or research question is that plastic particles introduced by tourism could contaminate the underground water supply. So if I find that there are plastics in the groundwater, the next thing I'd like to find out is if these plastics are getting into people's drinking water, into the sinks where people are washing their hands, because that could, you know, find their way into people by ingesting it. Okay. So my objectives, well, the first hypothesis is first figuring out if there's plastics present in the groundwater. And then I wrote here representative sample, because I want to make sure that I'm getting a good idea of whether, hold on, I'm sorry. The representative sample, meaning that I want to make sure I'm testing a large sample size, making sure that I'm getting a good representation, not just testing once and not but multiple. And then right there on C, it says test a gradient. So I'll be testing in this, you see this map to the right, there is a path, and that's called the Ruta de Cenotes. And as you get closer to the coast, it's more touristy there. And as you get further inland, they're less frequented by tourists, and these are more used by locals. So I suspect that there'll be more plastics closer to the coast, but that gradient is there to serve as a way to see, is there a change in the amount of plastics as we move away from the coast and further inland. And then the second objective would be, testing if there's plastics in the drinking water, and I plan to use student and faculty households, like the taps and different sources of water within the homes to see if there's any plastics there. And then if there's the opportunity, maybe even restaurants or water hoses, things like that. So here is a picture for the methodology. There's two methodologies that I've included here, the filtration process and the analysis. For the filtration process, first I have to gather my samples. And if you see the 3 jars at the bottom of the big jar, the samples, there's going to be many sample jars, and I'll have at least one for every cenote that I test. And there's a negative control, which that just means it's DI water. That's presumed that there's no plastic present in this, and that'll serve as a control. And then the positive control will be made by mixing 1 gram of polyethylene microspheres plastic, as well as 155.55 grams of isopropyl alcohol and 700 grams of DI water. And the purpose of the positive control is to have a standard of plastics that I know are in the water, and those will be injected into my samples as a spike, so that if I look at the samples under the microscope, that's the analysis portion of the methodology. If I look at these samples and I see the microspheres that I injected in, as well as other plastics that I did not put in, then I will know that there's at least the filtration process and the analysis is efficient. And I'll be able to see that there are plastics in there that I didn't put in. So I would assume, I guess, that those are coming from the environment, from the source of the samples that I'm taking. Okay, and then in the picture in the top right, that is called a manifold. There's 3 projections coming up from top, and those are that's attached to a motor or a vacuum. And as I will put a stainless steel funnel that's actually there in the picture, and the samples will be poured into the funnels. There's going to be a microcellulose filter in between, and that's just a very small filter that can capture anything. The ones that I'll be using will capture anything greater than 0.3 microns. So the plastics, as long as they're bigger than that size, I should find them there in the filters, and I'll run those little removable filters under the microscope. Okay, and then pitfalls and limitations. So the big thing is making sure that I'm not contaminating my samples with what I'm wearing, what I'm using. So I'll be using a room that's completely plastic free, ideally, but because there's so many sources of plastic. So that's one thing I want to make sure that I'm not putting additional plastic in, because I want to make sure that it's representative of what's actually in the cenotes. And then another limitation is the visual analysis. I'll be using the microscope, but like I mentioned earlier, I won't be able to actually test if something's plastic or not. It'll be totally visually. I'll have to just, I guess that it's plastic because it doesn't look like my microspheres and it doesn't look like any organic material. And yes, I can't test the actual identity. There is a method to do that, but that's outside of the scope of this research project, and hopefully somewhere down the line another student can pick up there. And then the other thing is, like I mentioned, there's not a lot of research on this topic right now, and most of what has been tested has been in a lab with microspheres that are made by different factories, and those aren't exactly representative of what I'll find in the environment, just because there's so many different kinds of plastics, and they all react differently. They're different shapes, and like I showed you earlier, there's the filaments, the fibers, the sheets, and the spheres are just kind of like uniform. So yeah, see how that goes. And then my expected results, I expect that there will be plastics in the groundwater, just because even when I go on walks and things like that, I'll see water bottles, chip bags, things like that in little rivers. And I assume over time with the wind, the water, it'll break down into smaller particles. And I think there will be this type of plastic, polyethylene terephthalate, which is water bottles. A lot of tourists are taking water bottles. Maybe they're taking their refillable water bottles, hopefully, but if not, they're purchasing water bottles, plastic water bottles. There's tourists that are going to the beach. Maybe they have small kids with them and they'll take toys. Those get forgotten or lost in the sand and then they break. down, or they get left somewhere near a cenote. I mean, probably not because there's no sand there, but also food wrappers. People aren't always cautious about throwing it in the garbage can, so it'll end up somewhere blowing around, and eventually it could make its way into the water. And I also predict that the water sources that are frequented by tourists will have the most amount of plastic, as opposed to the ones that aren't frequented as much by anyone, or the ones that are mostly visited by locals. And if I do happen to find plastics in the pristine locations, those being the ones that nobody really visits, that are more isolated, then that could lead to maybe a future project somebody could take over. I assume that there would be the conduit system, which is just the little pores within the aquifer, that the plastics would be somehow making their way in there, and that's pretty intense. It's a little scary to think about. And the significance of this study, I'm really excited to kind of fill the gap between the literature and the research, because there's not a lot of research on this. So I'm excited to find out for myself and hopefully share this information with other people. And then also just knowing that plastics could be a threat to human health. That's very important, especially if you're thinking about people are drinking this, and we don't know everything there is to know about the potential risks of plastic, but that's why this is important, because we want to find out and make sure that we can prevent any really dangerous things to people's health in the future. And let's see, and that is it. Thank you to everyone there.
Thank you.
Yeah. You want me to stop sharing?
Stop sharing.
Okay.
And so we'll see if there's any questions in the chat and any live questions. So there's the chat. I don't know if there's any questions there.
There isn't, but I just saw what Ken said. Thank you. It is just a conversation with slides. I should have read that before. I don't know why. Some days I get really nervous and some days I'm fine. Today it's just one of those days. I'm really nervous.
This is a big step.
Yeah.
I mean, for all of you guys, this is a big step. You guys went from traveling here, not really knowing what you're doing, and now all of a sudden, I'm presenting what I plan on doing for research. That is a humongous step to take in a week and a half. So you should be nervous. But you did a great job. You did a great
Appreciate
job.
it.
All of
Thank
you guys have
you.
done a great job so far. We got one last one.
Thank you, Ken.
All right. So is there any questions?
So as far as like microplastic research, there's very little research done on that
Yeah.
area.
Mostly in the salt water and the oceans, and yeah, just surface water, I would say, but not so much groundwater. Yeah.
Is there like a type, because you said there's two types of plastics, but is there a type of plastic that includes other chemicals that might make it last longer or something?
But that would probably be considered primary, just the way the companies manufacture them, and then secondary is just as it breaks down. So it's still technically the same plastic source, it's just smaller pieces, it's fragmented, yeah.
No, there are plasticizers. We're not doing that. That's beyond the scope of our research. Say, good job of saying that. Yay. I taught her that one. So that is one thing you guys all need to learn, is when someone asks you a question that you're like, oh, that's a really good question, but it's really not what I'm doing. It's beyond the scope of my research.
Yeah.
That is an appropriate answer when somebody asks you, those kind of things. But it's a good question. So,
Yeah.
okay, great. Great. Thank you. Yay. And last and definitely not least, we have our geochemistry talk, and she brought her presentation with her on a virtual flash drive. Excellent. Okay, let me get you started here. Let's not cancel. And then great job, everyone. Let's see, let me close this up. And let me go ahead here. Let's see, first one. Okay. And last but definitely not least. Okay, share screen. This one right there. We're going to share this one. There you go. We're going to start the presentation. It's going to start. Come on. Oh, Zoom slideshow. Oh, it's starting the other one. Nope, nope, it's up there. Why is it doing it there now? That's strange. Stop sharing for a second. Let me close up this one, and that probably will solve my problem. Okay. Didn't think it could figure out which one it was doing that. That's it. That fixed the problem. Okay. I'm going to go back to sharing my screen. I'm gonna go back to the first slide here and display settings. Okay, there you go. Okay. Go ahead, introduce yourself. We're gonna talk about geochemistry now.
Yes. Hello, everyone. My name is Dayani Davila, and I will be researching on geochemistry. The focus will be nitrogen and phosphorus as nutrient pollution, and we will compare the data from 2018 to 2021. First to start, as we all have shared about what it's Yucatan Peninsula, but it's always good to refresh, right? So the Yucatan Peninsula is made of the hydrology of karst limestones, which is mostly, or it's flat. We don't see as much soil, and there is a higher porosity, and that creates cenotes or sinkholes. And they are formed with limestones when they collapse and they are exposed to groundwater, and they are exposed, which then they produce fresh groundwater. And as the system in the area, it's connected and it has several fractures, which the water flow moves in different areas. Many of them are still unknown, but that's what we're gonna be going to doing the research, right? And there is also the only source for fresh water is from cenotes, so it's important to verify what type of water we're consuming, and most of the contamination is coming from inland tourism, which has increased since 2011, and now because COVID-19, we will know whether or not it has increased or not. And we also see swine production on the area of Yucatan, which is the north of the peninsula, as part of this nutrient pollution. So nutrient pollution, it's mainly from nitrogen and phosphorus, and the source it's from runoff from urban areas, as well as wastewater treatments and tourists in the area that we're researching. What happened is that when a high amount of nitrogen and phosphorus come into the water body, it over-fertilizes the surface, and it produces harmful algae blooms, and they decay after the time, and the amount of oxygen in the deepest zones of the groundwater area depletes, and the habitat of the marine life starts going down. So this can also affect the humans with hypoxia and anoxia, and it's important to identify these issues. The objective of this research, we will identify the geochemical processes in ocean pollution, which is nitrogen and phosphorus mainly, and we will try to identify these areas in the cenotes at an individual and global scale. The research question is, has COVID-19 reduced the amount of impact on the recreational use of cenotes at the Yucatan Peninsula? If this is true, do we see an impact of the nutrient pollution, nitrogen and phosphorus concentrations in the cenotes? And they come up with several questions as well, which we would like to find the main species or types and potential sources of nitrogen and phosphorus at different depths within the cenotes. We also would like to identify what are the geochemical parameters that control the speciation of nitrogen and phosphorus, which can be pH, and we will also see among the cenotes studied, which one shows the greatest contamination difference, and how does the fracture zone change this? And lastly, we would like to identify, is the groundwater under the standards for drinking and recreational use? The hypothesis is the nutrient pollution for nitrogen and phosphorus is slightly reduced in cenotes since 2018 due to COVID-19 impacts in tourism. But however, the sources for wastewater treatment and urban runoff may still influence the higher nutrient concentrations of cenotes, and the cenotes may have greater amounts of nitrogen, which we'll be interested on seeing. For the methodology, we will use the HydroLab probe, where it measures the depth, it measures turbidity, temperature, pH, conductivity, oxidation reduction, and also it measures dissolved oxygen. We will use the spectrophotometer, which is in the middle in the picture here. And it will look at nitrogen and phosphorus speciation, so different types like nitrate, nitrite, phosphate, and the amount of nitrogen in the entire system. We will also look at ion chromatography to identify the major ions, which will be the anions, the cations, for example, calcium, potassium, fluoride, chloride. And we will use the chemical sampler, which I think I didn't add a picture, but it's it will collect the water at different depths, and it will help us to identify the water samples at each of those depths. And the software that we're going to use is the Geochemistry workbench, which will help us analyze the data. The locations that we will be going is 3 of these cenotes, the Verde Lucero, which is a touristic cenote, and the Popo Bu, it's local cenote, and the Natunich is a pristine cenote, so we will be interested on looking into that. Actually, seeing into this, I think it's Popo Bu, it's the tourist, and it's vice versa, right? And Popo Bu is the tourist cenote. So yeah, so we're gonna identify those 2 cenotes. Unfortunately, because we're in a limited amount of time of collection, we will not be able to identify the main, how these sources are coming into the area, because we are only identifying it on July. There's also 3 cenotes that we're studying, and in one of them, which is the Natunich pristine cenote, it's in the middle of it's in a fracture zone, so the water flow on this location may be different, and we can find different areas. So it will be interested to see the groundwater chemistry, and the direct sources of contamination may vary because of the time set that we're studying, and as well as the people that are coming into. And some of the expected outcomes that we can see is that identifying the variables like depth, dissolved oxygen, we can see how is the dissolved oxygen changing in the system of the water body. For example, electric conductivity, as well as the pH on that system. But we will also would like to identify at each of the cenotes and at each of the depths, what are the changes and variables. And this is an example that some of the expectations, so we can see how they'll be changing in regards with the concentration. So here on our x-axis, we see the concentrations for phosphate and our depths from that location. We would like to compare that with different data from 2018. So here we will see at different depths the nutrients like nitrate, ammonia, phosphate from 2018 compared with 2019 and 2020, and hopefully 2021 this year, and see what years have we seen a shift or a decrease on these variables. We will also, with this data given, we will identify the thermodynamics, which examines the chemical equilibria controlling nutrient speciation in the system. And an example for this are the nitrogen and phosphorus species in equilibrium with the pH and also the EH. In this case, we would like to see, let's say that we have ammonium here, and in the system we found out that ammonium is above the equilibrium. So we would like to identify where is this source coming from. Is it coming from a local wastewater treatment area? That's something that we would like to identify. And by using the ORP, oxidation reduction, values, we will be able to find what is this. So it will be interesting to see the system at each of the specific depths. And we're excited to do this, and thank you so much for Dr. Ken, Dr. Mel, Dr. Kearney, and everyone here that it's in the NIU and CIS faculty, as well as my teammates.
Great job.
Right?
Yeah.
So hit the red button up there. It says stop sharing. Awesome. And then if there's any questions live or on chat.
Okay. Okay, it says, I think it makes me think a lot of, I think it makes, Juliet Luther says, I think it makes a lot of sense though. You made me think about what we saw in New York during the pandemic, especially at the early months. The skies clear up to the clear traffic, and wasn't like anything I ever seen there. There are implications for chemistry questions, complements for creative thinking. So,
Good job. That's great. That's great. Yay, yay.
Is there any questions?
Oh, no. So it's really exciting
any
that you
questions?
mentioned 2020 data too. You want to explain how we have data from 2020?
Yes, so the faculty went, and during 2020, while the REU was at their homes, they were collecting the data for them. So now we have data from the past 4 years. So, well, the past 3 years and this year, so we're gonna be able to identify any shifts of increase or reducing in the area.
So this is one of the great things about this is that continuation of data.
Yes.
Yeah.
So thank you for collecting the data.
Yeah, no, we collect, yes. It was rough. I had to, during the pandemic, I had to go to Cancun. It was tough. It was a really rough thing.
Right.
It was really rough, yes. So, okay, well, that was it for today. Thank you all. I'll just leave it alone and I will, oh yeah, get your, that is all for today. We will, we are done with the presentations. So thank you guys for staying around and hearing all of them. If you guys have any additional questions, at the end of this, so on August 13th, they'll be doing additional ones. So find out, come back and hear about what did they actually find out while they were down in Mexico. So thank you all. Okay. Make sure your presentations are uploaded to the Google Drive just so that we have copies of them. So please do that. Just so I'm going to stop recording. Stop recording.